Okay, for the problems on the back. So we got some more practice that we're going to do together, and then I'll probably have you finish. So we're going to definitely do 3 through 6, and I'll probably kind of guide you through 7 through 8 and check that to check your understanding. So recognize you always have two equations. That's why we have a system. So that's two or more equations. I'm just going to start labeling the equations A and B, equation A and equation B. And so we can identify which one we want to isolate for or which one is already isolated. So on number 3, the A is isolated for the variable y. Okay, y is already by itself. So that means we're going to take what it equals, which is what it equals is the 9x. That's why I'm circling that. And I'm going to substitute it into the y in the second equation. When I use substitution, I'm using parentheses. So when I'm plugging this 9x for the y, I'm now going to have basically x plus the parentheses is where the y is equals -10. So I'm just showing that so you can see that I'm plugging in for y the 9x. All right. So step 3 after the substitution is solve the equation. Here we do not need to distribute because we don't have a coefficient, we don't have a number in front of y. What we have are just like terms. X plus another 9x gives me a total of 10x. So now the equation is 10x equals -10. And we're going to solve for x by dividing each side by 10 by the coefficient. So x here equals -1. Once we get a value for the variable, our variable is x, we take it and plug it back in to what we circled, what we originally had isolated. So when I plug it back in, my y was equal to 9x. So now my y is equal to 9 parentheses -1. Remember, whenever we substitute, we use parentheses. So this is saying 9 times a -1. So the y equals -9. That's a negative, sorry. So our answer, our solution, is the point, the order pair, -1, comma, -9. This is our answer. All right, so to check it, we have to plug in the values that we have for this order pair, this x and a y, into the original equations. The first equation we had was y equals 9x. So that means our y is going to be substitute for the -9 and check to see does it equal 9 times the x, which was -1. Well, yes, it did. -9 equals -9. That works. Well, the second equation, equation B had x plus y equals -10. So I'm plugging in the -1 for x, and I'm plugging in a -9 for y, and I'm checking to see does it equal a -10. Well, yes, it does. -10 equals -10. It works. So this is the correct solution, the correct answer. Okay. Now, as you're watching this at home, if you have to pause it, you have to rewind and watch it again, do that. Okay. All right. So on number 4, this is when we're going to have to determine which is the easier equation, either equation A, the first equation, or equation B, to isolate for a variable, because none of them have a variable by itself. So the key to this is to find a variable, that's a letter, without a number in front of it. And that will be the easier one to isolate. If I look, equation A is the easier one because the x does not have a coefficient. So I'm going to change this to get this x by itself, which I have x minus 2y equals 4. To get the x by itself, you would need to cancel out the y by doing the opposite. If it's minus, now you have to say plus 2y on both sides. The 2y's would cancel, and we would get x equals 2y plus 4. So now the x is isolated. And this is what I'm going to plug in for that x in equation B. I'm going to plug it back in using parentheses. Plugging in is using substitution. So I'm going to substitute what I circled in for x. So to do that, you're going to need to use parentheses. So it'll be 3 parentheses, and inside the parentheses is what's inside my circle right here, which would be 2y, plus 4. That's inside the parentheses. Then I would write plus 4y, continue writing the rest of equation B equals 32. Step 3 in our notes tells us to solve the equation. Usually we're going to have to distribute and solve for the variable. So we would have to distribute the 3 here. So that would be 3 times 2y, which would give you 6y, plus 3 times 4, which would give us 12, and plus 4y equals 32. What we recognize hopefully now is that you have like terms that you can combine. If I take my 6y and add it to this 4y, I have a total of 10y. So 10y plus 12 equals 32. So to solve for the y, you're going to need to isolate it by getting rid of the plus 12. So this would be minus 12 on both sides. My 10y equals 20. When you divide that by 10, obviously you see y equals 2. So now that I have that value, I can plug that back into what I had circled, okay, to get my x. So when I plug it back in, x equals 2. Remember, substitution or plugging in, use parentheses. So it'll be 2 parentheses 2, because 2 is what the y equaled right here. This y is now 2. And then we have plus 4. So 2 times 2 would give me 4, plus another 4, which means our x equals 8. So our answer is 8, 2. Now I can check it by plugging in our x and our y for each equation. When I do it for equation A was the x minus 2y equals 4. I got to check to see if this is true. That's why I put a little question mark here, right here. So this is 8 minus 2 times 2. Would that equal 4 when I work this out? 8 minus 4, yep, equals 4. So 4 equals 4, so that is correct. All right. Now I'm going to do the same thing for equation B. Equation B was the 3x plus 4y equals 32. But I'm going to substitute my x, which is 8, and my 2 for y. So this would be 3 parentheses for substitution. Use parentheses. 3 parentheses 8 plus 4 times parentheses 2. So 4 parentheses 2 equals 32. And so this would give me 24 plus 8, which is 32, equals 32. Yes, it worked. So my answer I solved and got is correct. So I know I did it correctly when it's true, or when it's the same solution for both equations. All right. All right, so let's try 5. Remember, we have 2 equations, and we have to pick the variable that is easiest to solve for. Okay. The one that we want to isolate, the easiest one now on this one, would be actually the B. Because, yes, they both have a y that does not have a coefficient, a number in front, but this one's positive, and I want positive variables. I don't want a negative one. So to change this into solving for y, you would have to subtract the 4x on both sides of the equal sign, which means this would change into y equals negative 4x plus 9. That's my equation B now. Now that I have the variable isolated, I can take the value, or the expression they have for this y, which is this negative 4x, circle that. And that is going to get substitute into the original equation A for y. So to use substitution, or to do substitution, you have to use parentheses. So when I write this out, you would have 3x minus parentheses. Inside the parentheses would be the negative 4x plus 9. Close the parentheses. Then it's going to equal 5. And the only thing we now have to remember is whenever we have a minus in front of the parentheses, that's like a negative 1. You have to remember there's a 1 right there to put that coefficient of 1. So I can now distribute that negative 1 inside to the expression. So this comes out to be 3x. Negative 1 times the negative 4x now makes that positive 4x. Negative 1 times that plus 9 now makes that a negative 9 equals 5x. So from here, I can combine these like terms of 3x plus 4x, give me a total of 7x. Minus 9 equals 5x. And then normally I would say, guys, solve for or start with the smallest variable. Did I write that right? Oh, where did I get the x from? I'm sorry. I don't need an x. It's supposed to be just 5. Sorry about that. So that lets me have a different conversation here. Sorry. Okay, so now to solve for this variable x, we need to isolate it by doing the opposite of this constant, which means instead of having a minus there, we're doing the opposite. So that's plus 9 and plus 9 on both sides. So the 9's cancel, giving us 7x equals 14, which we know x equals 2 when we do that. So now I'm taking that 2 and I'm going to plug it back into my circle expression, because I'm plugging the 2 in for x to solve for y. So that means my y would equal to, whenever we substitute or plug back in, we use what? Parentheses. So this will be parentheses 2 plus 9. And now I'm doing the operation. 4 times 2 will give me, negative 4 times 2 will give me negative 8 plus 9. So my y equals positive 1, which means my order pair is 2, 1. And so now I can check it by plugging in the values 2 and 1 for my x and y in both equations. In the first equation A, I'm just going to go straight to substituting using the parentheses. So this would be 3 parentheses 2 for the x minus parentheses 1 for the y equals 5. This is really just saying 6 minus 1. Does that equal 5? Yes, 5 equals 5. So that's true. So the point is true and it's correct for the first equation. Then we're going to do the same thing for equation B. Here I'm going to do 4x, which is 4 parentheses 2. We're going to plug in or substitute 2 for x, then plus 1. Would that equal 9? Well, 8 plus 1 is definitely going to give me 9. So it works. So this is definitely our answer to our system. Okay. So let's just try one more. Let's try the last one. And then let's talk about some special cases on the second page, on the last page. So I want you to do number 6. Go ahead and just kind of pause the video. I'm probably going to pause my recording just a second here and plug and come back and check. 6, I think, is a little easier because the variables are already isolated. So you can pick either one, but I'm just going to go with the first equation and plug it in the expression 3x minus 7 in for y in the second equation. So that's our setup. Sorry. Hopefully you've written 3x minus 7 equals a negative 2x plus 8. So see if you can get to the value of x. You needed to add 2x on both sides first. to solve for to cancel out the smallest variable, which is the minus 2x, and now we can solve for x. All right, so we should get x equals 3. Now you have to take this value and plug it back in to our original equation, which was the y equals 3x minus 7. So try to see if you can get to the solution. Pause the video, work it out, then unpause it, come check your answer. All right, you should have came up with 3,2, and then I'll let you check and see if you did it correctly. Now, on our last, let me minimize this, set of equations here to use substitution, 7, you would need to pick the easiest variable to isolate, which would be the first equation, the x. Okay, so we want to solve for x. By getting this x isolated, you're going to end up having to add 3y on both sides. So that means x would equal 3y plus 4. And now that kind of lets you get started. Now, I want you to do 7. You're going to do the same thing for 8. But I'm going to talk about 9 and 10. 9 and 10 are special cases. Okay. I'm going to just put a little special example or cases. Now, you're still going to go through the same 4 steps, which is to isolate the variable. If one is not already isolated, we have to pick the easier one. So on number 9, the easier variable to solve for is the second equation for y. Okay, I can do that by just adding x on both sides of the equal sign, and I get y equals x minus 6. Okay, so now I can take what I have for y, this expression x minus 6, and now I can plug that in for y in the original first equation. So when I plug it in or substitute, I'm going to have to use parentheses. So make sure you use parentheses. So this means I would have 4x minus 4 parentheses x minus 6 inside the parentheses equals 24. And now to solve for this equation, you're going to distribute first. So that would give us 4x minus 4x plus 24 equals 24. But when I solve this, we have like terms, and when we combine them, they become 0. Sorry, that's a 0. So I'm left with 24 equals 24. Well, this is a true statement. Anytime we have a true statement, then the answer, our solution, is infinite. Solutions, which we have a symbol for that, which is infinity. Now, anytime I have infinite solution, that means we have basically all real numbers. And we have a symbol for that, which is this double R. Okay, so those are just the same. So if the x's cancel and you're left with the true statement, it's infinite solutions. Now, if you look at number 10, okay, we still have to pick which variables is the easier to isolate. And in here, it would be the second equation for x, because x doesn't have a number in front. Like this x has a number 2 in front, this one doesn't. So to do that, you would add 3y, eliminate the other variable. So this would give me x equals 3y plus 4. All right. So now that the x is isolated, I can take its value, hopefully we're still there, the expression right here, 3x minus y, and we can plug it in for the x in the first equation. So that means to plug it in or to substitute it in for x, you're going to use parentheses. So 2 parentheses. Inside the parentheses is the 3y plus 4. Close the parentheses, rewrite minus 6y equals 20. And then we're going to solve this for y, which will cause us to distribute. And that means we would get 6y plus 8 minus 6y equals 20. Again, we have like terms. We're going to combine them. But when we combine these, again, they become 0. They cancel. 6y minus 6y is 0. And you're left with 8 equals 20. Well, this is a false statement. This is false. If you have a false statement, then you have no solution. Which means you have the symbol for no solution is a 0 with the line going through it. Okay. All right. So I just want to make sure you have those. Make sure you finish the notes. So you're finishing 7 and 8. And make sure you did the last problem over here, number 6, correctly. And you're submitting when you're done. Thank you.